All right, let's get going. Good morning, everybody. Welcome to day 56 of our class. Today, as mentioned in the email you got this morning, we're going to start going over chapter 19 in the Muroc text. That is an introduction to database or databases. We are in the last section of the book. Chapters 19, 20, 21, and 22 are all on databases. Now, not to confuse you, and I'm not sure how far we'll get in this today, but one of the first programs that we're going to write in here, I'm actually going to bring in something from chapter 22. It's not difficult. You're not going to have to do anything special with it. It's just going to be a control that we're going to drag in because I think it'll make it a little easier when we create we'll create our first program. All right. As it says, what the plan is to spend all week on chapter 19. Now, what does that mean? Well, if we can get what I want to get through today, tomorrow, and Wednesday, then Thursday and Friday will be lab. If it takes 4 days, then Friday will be lab. So again, as always, we'll just see how it goes. All right, your chapters 17 and 18, homework and written tests are due now this coming Sunday, the 7th. Remember, for chapter 17, all you have to do is the written test. All right, that was the stuff in there that was on file IO. For chapter 18, you are expected to do both the written test and the 3 homework assignments. Those were that employee search that we did together, the song search that we did together, and I want you to at least attempt that student rate thing on your own. All right. So that's where we are. So let's get started. I'm going to do this a little bit differently. So again, this is where we are, right? So we're on here, intro to databases, as it says. All right. And we're either going to spend 3 or 4 days on this, and the rest of it'll be lab. Then notice, starting next week, my plan and my hope is Monday and Tuesday I'll lecture for the next 3 weeks. Wednesday, Thursday, and Friday will be lab. What does that mean? That means you're going to get an assignment for chapter 19. You're going to get an assignment for chapter 20. You're going to get an assignment for chapter 21. You're going to get an assignment for chapter 22. I'm not sure what those are yet. I haven't written them. All right. And then the very last week of class will all be dedicated for you to be able to go in and work on your final project that we'll talk about either at the end of this week or the beginning of next week, and your electronic portfolio. All right. So again, we're on day 56 today, which means 24 days after today. All right. Okay. So in other words, 4 weeks from this Friday will be the last day of class. All right. Now I sent you this file right here, and we're going to go over some of the stuff in here. And I expect probably once we get down to this point, very little of it will make sense. But I'd just like to go over it with you because there's a couple things that I want to mention in here. So first, we got these 2 things from LifeWire. The first one is called Database for Beginners, and it's right here. And I last thing in the world I want to do is read to you. All right. Now, most people will define a database as an electronic repository of information. And that's a pretty general or a pretty generic term. Most people do equate databases with something electronic. Now, that said, tell you a very, very quick story, and it is. All right, one of my wife's best friends, this must have been about 5 years ago. She went into a mall, and don't ask me why she did it. I have no idea, but she left her purse in her car. All right. And when she got back into her car, her purse had been broken into. All right. The car was broken into, the purse was there, but her wallet was gone, etc. But she told my wife later that it was all okay because that stuff could all be replaced. But what she had in her purse was her daily planner. And literally, she had her life scripted in that daily planner, and that was still there. She said she could always replace credit cards. There wasn't much cash in there, but she couldn't replace that daily planner. In other words, in her mind, that was her database. All right. Now, ours is going to be, of course, a lot more complex than that. We're going to create several databases as we go on. And there's a lot of different packages that you can use to create databases. Just so you're aware of this. I mean, as an example, let's just assume for a second that you've got Microsoft Office. And I'm not saying you do or don't, but let's just assume you do. Well, one of the things that's offered in Microsoft Office, and I guess I'd have to get it differently on here, is a database package called Microsoft Access. All right. And it works just fine. It's a good database. It's not hard to work with, but it's only meant to support maybe 10 different people using it at a time. So if you worked with at a company that had 100 different users, you wouldn't use Microsoft Access if they all needed to use the database. It would just be too much. Instead, you'd use the one that we're going to use in here, which is SQL Server. We'll talk about that in a minute. But there are other ones as well. There is a really popular free open source database called MySQL, sometimes called MySQL, and it's owned by Oracle. Oracle is another database system, and it's not free. And in fact, the person who runs Oracle is one of the richest people in the world. All right, and there's other ones too. So what can a database do? It can do a lot of different things. The reason I put this in here is this paragraph basically in here. And what I mean is there are several different types of databases. In this class, in our class here, the type of database that we're going to learn about is a relational database. Now, you might say, well, big deal. It kind of is, because really relational databases now are approximately 55 years old. All right. And they're still very, very popular. There's other kinds of databases. All right. When you take the AWD1100 class, which is Database Driven Web Development 1, when you take that class, you learn about a database called MongoDB. And in that class, that's called a NoSQL database. But we're going to work in here with a relational database that is an SQL database. All right. And the reason I bring that up, I'll always remember this. When I was in high school, which is about when all this stuff started, we got our first computer when I was a senior in high school. When I say we, the school did. All right. And I remember them bringing it in. It was humongous. I would guess it was somewhere about 50 to 100 feet long and about 15 feet wide. It took up most of the office. It was loud, etc. But at the time, it was considered fantastic. Now, today, you could go into a store, go into a Walmart or whatever, and buy a calculator for about 10 bucks, which is probably about as powerful as that computer was. And so again, why am I bringing this up? Well, there was a mathematician, his last name was Codd, and he was the one who started this whole thing with relational databases. And what I'm saying to you is if we're working with relational databases and they're still popular 55 years later, just imagine 55 years ago what computers looked like. I gave you a couple examples, but how many things from computers 55 years ago are still being used today? Well, one of those that is being used today, all right, one of them is relational databases. All right. Okay. So they go through here and they talk about the structure of a database. I'm going to give you my own things on that in just a minute. Okay. So we'll talk about that in a minute. One of the biggest strengths of databases is the fact that you can query a database. When you query a database, what you're doing is you are requesting information from the database. Now, they mentioned reports there. Of course, you can make reports based off of your queries, but the idea is with queries, you can in fact, you may have heard of the term data mining, where sometimes you've got millions of pieces of information and you only might want a few things out of there. All right. And that's the kind of thing that you can do. We're going to look at some of that kind of stuff. As far as the common database products, some of these I mentioned to you. MySQL, the one we're going to use, which is Microsoft SQL Server, and Oracle. All right. And I will tell you, most people say, not everybody, but most people say that this is a great way to end the class. They kind of like what they're doing here. They find it not that it's easy, but that it's intuitive to work with, and it's fairly straightforward. I hope you're going to feel that way as well. All right. So there's another article in here by these same people, and it has a lot of different definitions in it. Now, I could go through every definition that's in here, not to be funny, mean, or whatever. Probably you'd remember very few of them. So what I want to do is just hit you with a couple of the high points. That's it. All right. So like I said, I'm not going to go through every one in here. We will talk about what an attribute is. You're going to see that by the end of the period today. And an attribute goes by a lot of different names. All right. We're going to start talking about constraints. In particular, today, we'll talk about those bottom two constraints, which are a primary key constraint and a foreign key constraint. My hope is, after going through some of this stuff, some of it starting today, what we hope to be accomplishing here is going to make some sense to you. That's all. All right. The next thing is a DBMS. Now, I mentioned to you already, Microsoft SQL Server, Microsoft Access, MySQL, and Oracle. Those are four different examples of DBMSs, database management systems. And even more so than that, if you look at that last sentence in here, they're all relational database management systems. As I mentioned earlier, when you take the AWD1100 class, you will learn about MongoDB, which is not a relational database management system, but it is a database management system. And more than anything else, what these database management systems allow you to do is to work with data in a fairly standard type of way. All right. And if you can get that, that's cool. All right. Entity next. We are going to, not today, but we are eventually going to talk about these things. And those are an entity relationship diagram. And it'll look something like this. And don't let it throw you. No, you're not going to have to create these, etc. But no, I want to explain to you what some of that stuff is. Not today. All right, but we will talk about it. But stuff like functional dependencies, etc., I could go into it with you. I'd explain it to you. You may understand it, you may not. But not to be funny, you'd probably forget it fairly quickly. All right. Some of these I've already mentioned to you. A primary key, let's keep it real simple. A primary key, three-word definition, a unique record identifier. What the heck does that mean? This is what today is about. So we're going to start talking about that. All right. A foreign key is how you basically are able to relate database tables together. That's what makes up a relational database system. All right. There's all sorts of rules that you can use with this. All right. And these rules include normalization. All right. And I'm not going to lie to you either that this is probably my favorite part of the course, because when I went on and got my master's degree, all right, I did my thesis for my master's degree on relational database management systems. All right. And yeah, it's been quite a few years since I did that, but still, this stuff still pertains today. I could pull out that thesis, which is several hundred pages long, and still use the information in there today. And one of the things I would talk about then would be normalization. All right, NoSQL, I already mentioned that an example of that is what you'll learn in the AWD1100 class, and that is MongoDB. And I do want you to understand, NoSQL doesn't mean there isn't SQL. You're like, what? No, NoSQL, this means not only SQL. That's what the no stands for. All right. Okay. Null. We've talked about null in class here. Null is something that's unknown. If this is the first class that you're taking at Rankin, the day you walked into class or, put on your machine, whatever, for the first day of class, you didn't have a GPA. Your GPA wasn't 0. It was null. It's unknown. Now you have some kind of an idea about what your grade, at least in this class, is. All right. Queries, as it says, they're typically written in SQL. That's what we're going to be doing. We're going to be writing 4 different types of queries in here. And I don't even think I put that in what I showed you before, but we are going to be writing what are called select queries. We are going to be writing what are called insert queries. We are going to be writing what are called update queries, and we are going to be writing what are called delete queries. All right, we'll talk about what all that stuff means in just a little bit. All right. Not only that, one of the terms that you're going to hear that's related to this, and it looks kind of funky, but we're going to look at a term that's called CRUD. And CRUD is an acronym that stands for create. So create replaces the word insert. All right. Read, which replaces the word select, update, and delete. That's what CRUD stands for. So the hope is by the end of this semester, you'll understand what CRUD is, and you'll be able to write CRUD queries. All right. When you start to write these queries, you have to work with a database, and that database has to have some structure to it. We're going to look at that in just a moment. But that structure that the database has is known as the database's schema. All right, so you're going to start looking at schema in just a bit. Structured query language, I mentioned already. And again, about 55 years old, used with relational databases, and really with non-relational databases as well. But it allows you to write those 4 types of commands. Select, insert, update, and delete. Now you'll notice in here too, they talk about 2 different terms, or at least one right here, and they talk about data definition language. All right, so what I'm going to mention to you in just a little bit is we are going to talk about DDL, which is data definition language. And then we are going to talk about DML, which is data manipulation language. Now, it's not that important that you remember or memorize every single term that's in here. What's more important is that you understand what the terms mean and that eventually you're able to create programs that implement this stuff. That's what we're shooting for in here. All right. And that's about it from here. Okay, so we talked about a couple things there. Again, I'm not going to go into this entity relationship diagram right now. We'll talk about it, just not right now. So let's jump back into here. All right. So when you look at it, if you look at lines 7, 8, 9, 10, and 11, they may make sense to you. They may not. All right. A character, as it says, is basically anything you can key in. So if you look at your keyboard, it's any character on there from which you can type something in. If you put one or more of those characters together, you get what's called a field. Now it goes by other names as well. That's not important right now. All right. But a field, as it says right there, is one or more related characters. What do you mean one? Well, what if you had a field that was called middle initial? That would be a single character. All right. If you put together, let's just say as an example, first name, middle initial, and last name, those would be three fields that you could put together and from which you could make a record. And you could have as many of those as you wanted. I could have 12 of them for all the people who are in this class. So for each one of you, I could have your first name, your middle initial, and your last name as an example. So that would be 12 records. Those 12 records would go into a table. Now, a database can be as small as one table, but typically a database will have multiple tables in it. Depending on how the database is set up, it's not impossible that the database could have literally hundreds of tables in it. You don't typically see something that's that big. All right, typically if it's going to be that big, you're going to break it up into multiple databases, but it is legitimate to do something like that. So again, one or more characters make up a field, one or more fields make up a record, one or more records make up a table, one or more tables make up a database. So if you look down here, this is an example. And now this is taken from one of the things that I gave you last week. And I don't know if I even have it up here or not. Where is it? Yep, it's right here. This is one of those URLs I gave you last week that's called Building an Employee Database with SQL Server Management Studio. But I changed it around a little bit. Why? Because I don't like the way they did it. All right, so I made my own. Now, a couple of things about this. This right here, this thing, right in here, this is known as the database schema. What that means is it's got the name of every field that's in this table called employees. If you look, there are 6 fields in there. One that's called employee ID, one that's called first name, one that's called last name, one that's called age, one that's called salary, and one that's called type. All right. Not only do we have those 6 names in there, but each name has associated with it a variable type. So you'll notice that the employee ID is an integer. It's a whole number. Okay. First name and last name are what are called varchars. What the heck is a varchar? That means variable length characters. That means that a first name will typically be between 1 and 50 characters, and that a last name will be between 1 and 50 characters. Now that's pretty big. Do you really need it to be that big? No. Could it even be bigger? Yes. All right. Age, as you can see, is another integer. And integers are just what we've been working with all semester. Varchars are basically like strings. Ints are ints, decimals are decimals. All right. So age, salary, which is a type decimal, and type. All right. The one you may or may not understand is type, and we're going to talk about that in a minute. All right. So this is a command. It says I want to create a brand new table, and I want to call that table employees. All right. This then is the schema for that table. In other words, it is a listing of all of the fields that are in the table employees and their type, and if it pertains to that, their length. All right. What this is known as, if you remember, I just showed you a couple terms here. When you set up the schema is called data definition language, because what you're doing with the schema is you're defining what the pieces or parts or portions or whatever you want to call it of your database are going to look like. So as of right now, we've got a database with one table in it. That one table has 6 fields in it. All right. Each one of those fields has a name and a type. All right. Then what you see next, right here, this insert, this is an example of a data manipulation language command. All right. So when we worked with data definition languages right here, there's really 3 commands that you use with this: create, alter, and drop. We're going to talk about what all those mean eventually. When you've got a DML, it's insert, update, really select, and delete. Now, normally when I do this, I put this one first. All right, and I don't know who taught me this a long time ago. It's kind of dumb, really. But when you look at this, to remember these, C, A, D, CAD. All right, and in here, if you do this, let's move this around. Again, like I said, I don't remember who taught me this. It's kind of dumb, but STUPID. So CAD and stupid. All right. But you see on the file here, one of the data manipulation language commands. Insert. What is that doing? That is inserting 1, 2, 3, 4, 5, 6, 7, 8, 9 records. It is inserting 9 records into the table called employees. And when you look at this, you can notice that each employee has his or her own ID number. This right here, this field, and I didn't put it in here because I didn't want to throw too much at you. This field would be called a primary key. That means that each one of these must be unique. That means no 2 employees can have the same employee ID. All right. And I'm looking right now, for example, at my rank and badge. And I'm looking here, and it does not have on it an employee number. Okay. I didn't know if it did or not, but it does not. I don't know. But the point is, when you look right there, each employee has his or her own employee ID, his or her own first name, his or her own last name, his or her own age, his or her own salary, and his or her own type. All right, we're going to talk about the type in just a second. But again, what I want you to get across here is we have a table that we created using a data definition language, or a DDL create command. Then we fill the table with data, and we filled the table with data based upon a DML command, insert. All right. And you'll notice in the syntax here, the way it looks might look a little quirky, just so you know, when you use commands like this, these commands that are right here, they're totally case insensitive. So I could have put all that you see right there, all into uppercase, all into lowercase, mixed case, etc. What I tend to do is I tend to take keywords, create, table, insert, into, values. Those are all keywords. I tend to uppercase keywords. All right. A lot of books would show you with this, For example, this would be a little e, this would be a little e, this would be a little f, this would be a little l, a little s, and a little t. Big deal. It doesn't matter. All right, if you're more comfortable doing it that way, you can. If you're like, well, forget you, buddy, I just want to do mine like this, you can do that too. It doesn't hurt anything. To my knowledge, there is not a relational database management system package like this that is going to be case sensitive. I could be wrong, but I don't believe that I am. All right. Okay. Now, when we keep looking at what's in here, then if we just keep looking, we go down here. Now you'll see we've got this. I'm going to make this a little bit smaller so we can see all of it. There you go. So you saw the employee and you saw its schema up above. All right. And the last field that was in here is type. That type that you see there, 1, 2, 3, 4, 5, or 6, those are these types that you see right here. All right. Now, in the example that was given, that I gave you this thing, whoops, where is it? I'm going to close a couple of these so I don't lose my way here. This one, the example that they used is, first of all, they said they called it employee demographics. I don't know why, but they had employee ID, a first name, a last name, an int, and a gender. I kept all those. Then they said you can add additional key value pairs. Well, this is very politically incorrect. You never ask somebody their ethnicity, their beliefs, etc. So I said, forget all that. Just get rid of that. I didn't use it. But then in here, they had another table called employee salary. And they said that each employee has got a name, an ID, a name, first name, a last name, an age, and they have a gender. Okay, fine. But when you look at this, I don't know why they broke it up the way they did, because each employee also has a type and a salary. There's nothing wrong with what they did here. I want to say that to you. What they did here, there's nothing wrong with it. But, and this is a big but, no joke intended there. Imagine you had 1,000 employees. And let's say it was a very good mix. So you had about 200 accountants, about 200 salespeople, etc. There's a pretty good chance that some people are going to put accountant in there and they're going to spell it wrong, or they might put in ACCT. Some people might type out human resources, etc. So there's a good chance. Plus, it's a lot of typing for somebody to do. All right. If you've got to put, for each employee, if you've got to put in his or her job title or whatever you'd call that. But if you look at what I did, and again, I'm not patting myself on the back or anything, but you only have to put it in once. Then each employee, rather than having a title, they've got a type. All right. A lot less typing, again, no pun intended, that you have to do right there. It makes much more sense to do this. Plus, it brings in something else that's very important in here, and that is the following. Let's say that my boss comes up to me and says, Jeff, I want you to create a little report for me. Okay, what do you want on it? I want every employee's first name. I want their last name. I want their job title, and I want their salary. So in other words, they don't care about any of these fields here. We don't care about that field. We don't care about their age. We do care about first name, last name, and salary, but we don't want to print out that Jim Halpert is a 1, Pam Beasley is a 2, etc. No, We want to be able to do what's called join information together from these two tables. So I'm grabbing from this table the first name, the last name, and the salary. I'm grabbing those 1, 2, 3 fields. And then from this table, I'm grabbing the job title. That's what relational database management systems are all about. And what I mean there, all right, is what you want to be able to do is design a database and design it in such a way, all right, that the tables, all of them directly or indirectly, are related to one another. All right, now this is a very simple example. I want to show you why I decided to do it like this as opposed to jumping right into our book. All right. So this is from our book, okay? And again, don't get me wrong, I'm not ripping on Muroc for this, but there is something in here I would never have done. All right. And what is that? I want to show it to you right now. All right, where is it? There. Here is the database that they're going to be using. All right. Now, just so you know this, if you look in here, you'll notice that every single one that's in here has got either 1 or 2 fields that have a little key by them. That means they're a primary key. That's the unique record identifier. So each customer must have his, her, or their own customer ID. Each invoice has its own invoice ID. Each state has its own state code. Each invoice line item has a combination of its own invoice ID and product code. Each product has its own product code, and each order option has its own option ID. All right. Plus, if you notice in here, when you look at this, because it looks a little goofy, you'll notice there's a key there. And then when it goes to another table, and there's like an 8 that's sort of, in some of these at least, the 8 is sideways. That's showing what's called a relationship between the employees. Where you've got the key, these are all what are referred to as one-to-many relationships. What that means is every one customer can have 0, 1, or more invoices. All right. Every one state code can have 0, 1, or more customers in that state. All right, etc. And hopefully you get the idea. What I don't like about the example that they gave right here is they've got a table that I say is kind of out on an island. It's out there by itself, and that is order options. So right now, there is no way, there is nothing that is equating the order options table with any other table that's in here. And I was always taught, pardon my French, that was a piss poor relational database design. How do you get around that? We'll talk about that in just a bit. Now, what if I wanted customer here, and and don't ask me why, but let's just say I wanted a customer's name and address, and I wanted something like the unit price of whatever products they'd ordered. You can say, well, you can't. There's no field in here in common. Yes, there is. What you'd have to do would be to join this table to this table. Then you would join this table to this table. Finally, you would join this table to this table. And then you could get the pieces of information you needed. That's what this stuff is all about. I have heard relational database technology described by some people, at least, as being kind of like a puzzle. All right, where you can fit stuff together. But in some ways, at least, yeah, it's like a puzzle, but it's like a puzzle that you can put together in different ways. All right, and still get the information that you want. If all I want is for every customer, I want their name, address, and their ID, I would just have to join together these two tables. And when you join together two tables, they have to have a field in common. Customer ID, customer ID. All right. State, state name. They don't have to be the same name, but they have to be the same field. All right. Invoice ID, invoice ID, product code, product code. All right. And that's what they're showing here. So again, that's what we are going to start talking about, getting into, however you want to put it. All right. Now, as we go on in here, and I didn't send this to you, I found it a little bit later. All right. But I found this. I thought it was pretty good. Okay. This is called How to Create a SQL Server Database. And I will send out the URL to this later. It isn't perfect. All right. But it's not bad either. So what I'm going to do between now, all right, between now and hopefully at least between now and the break, is try to use the steps that are in here. All right. And I'll let you read those on your own. I'm not going to read them to you right now. All right. But one of the things I want to tell you, all right, is if you remember when this was much earlier in the semester, and I mentioned this one other time, and that is that, let's see. If I go down to I think it's the V's in here, I've got the Visual Studio installer. All right. And that shows, if you remember, when we went and installed everything at the beginning of the semester, that's all the stuff that we installed. So, all right, I'm not going to go over here or anything, but the point is, if we look at what's installed, yeah, that's Visual Studio. But if we go out here, and let's see, if I go to more, there were someplace in here. There were a bunch more, but remember what I asked you to do at the beginning of the semester when we went in. I told you to choose basically the C# desktop, and that's what we've been doing all semester. I said you could do the ASP.NET, especially those of you who are going to be taking the the AWD1100 class in summer. The rest of you will probably take it in fall. I don't know, maybe in spring of next year. I'm not sure. But the other thing I'd asked you to put in there was, all right, databases. So how do you know whether or not you've got what you're going to use in here? I'm going to show you that right now. And I'm going to show it to you in two ways. First, I'm going to go down into my search box right on the bottom of my screen here. It might be hard for you to see, but I'm going to click in there and I'm going to type in SQL Server Management Studio. And you can see if you've got one in here when you do this, if you have one, yours might be a later version than mine. Yours might be 22 or 19. It doesn't matter. It should pretty much work the same. The other way you can see whether or not you have that is you can click on your button here way on the bottom left-hand corner, and you can go in, and I believe it's under Microsoft. Now, I could be wrong here. Microsoft SQL Server Tools. And there it is. Microsoft SQL Server Management Studio. Now, let's say, hey, Jeff, wait a minute, wait. I looked and I don't have that. If you don't have it, then what you're going to want to do, and I wouldn't do it right now because the install takes quite a bit of time. But what you'll want to do is type in Microsoft SQL Server Management Studio download. All right, and then hit enter. Now, the one you're going to want is going to be from Microsoft. That's the one I'd recommend at least. All right, and if you look here, we've got under learn.microsoft.com, download SQL Server Management Studio. And if you look, it couldn't be much more up to date. March 19th, 2024. That's pretty doggone good. So if I click on that link, all right, they'll have a bunch of stuff in here. Read it at your leisure or don't read it, whatever you think. But notice right here, you can download it right there. All right. And again, it is not small. Far as I remember, it was somewhere, I could be wrong here, but I thought it was about 9 gig. All right. I could be wrong. But if you click on that, what's going to happen is eventually it's going to do a download and put it in your downloads folder. Then you just follow the steps. All right. Now, let's say you start doing that and you're kind of confused. All right. And you're like, man, there's tons of junk in here. Do I really need all this, et cetera, et cetera? Well, as I mentioned to you earlier, I've also got in here this thing, how to create it. Now, it's a little more dated. It's about a year old, right? A little less than a year old, 11 months old. All right. It'll be a year old in 4 weeks. All right. But if you look in here, the first step they say, steps. Number 1, Microsoft SQL Server Management Studio. Now notice theirs is version 19, which is I think the same one that they had there. So it says install it. So it explains it in here as well. All right. So you can follow the steps here. But this is the key thing right here, what you see on your screen right now. And what I mean is, okay, I'm going to be doing some of the stuff in here a little bit differently than what you've seen before. What the heck does that mean? All right. Well, to show you, I want to get to this screen that you see right on your screen right now. All right. And I'm going to start up Visual Studio, but I'm going to start it up in a way we've never started it up before, unless you did it accidentally, probably. But if you look way over here on the bottom right, it says continue without code, which means I'm not going to start a project right now. I want to say that again. I opened up Visual Studio and I'm choosing continue without code. As of this second, I don't care about C#. So I'm going to click continue without code and I'm going to click on there. Okay. Okay, fine. Well, kind of looks like what we've had before, except there's no toolbox, there is no properties window, there's no solution explorer, there's no form designer. Yeah, and you'd be right. All right. But what you can do is you can go to view, and under view, there's different ways in here that you can get to this stuff. If you notice, there is what? There is a Data Lake Analytics Explorer, which I've never used. There's a Server Explorer, which I've used. There is an SQL Server Object Explorer, which I've used. All right. But what I'm going to try to do from here is I'm going to just type in just exactly what we put in here, Microsoft SQL Server Management Studio. All right, notice it's bringing it up. I've got it loaded. Mine is version 18. Yours is probably going to be version 19. Now, what you see on your screen here, I'm going to take this and I'm going to blow it up. Why? I want you to understand what the stuff that's in here means. All right, so I'm going to make a picture of it and I'm going to bring it up and I'm going to make it bigger. All right. So as you can see, it says SQL Server. All right. The server type in here, you should never, ever, ever have to jack with. There are other types in here than database engine, but you should never have to work with those. The next thing that's in there is going to be, yours might be the same as mine, yours may be different. All right. This just says, this is the name of my server, local DB, which is my machine, MS SQL local DB. That may not sound important, but when you're in the AWD1100 class and you're working with databases, you're going to be using that basically in almost every program you do. All right. The next thing that's in there says authentication. And you can't probably tell from here, but there's two types of authentication. Notice that by default, which means unless you're told otherwise, your default type of authentication is Windows authentication. And what that means, what Windows authentication means is if you're logged in to your Windows account, if you've logged in, so you're in Windows, you can get to the database. However, if you look here on the screen, I'm going to bring this back up. I know it's hard to see, but notice under database engines, there is database engine analysis services, reporting services, integration services, and Azure SSIS integration runtime. I don't even think in any class here you ever choose anything except database engine. All right. But the other ones are more for reporting and higher level things. Under the server name, if we had other servers that we were connected to other than our own machine, you'd see them in there. All right. Now, why am I telling you that? Because this is what I just mentioned. We're in Windows authentication right now. If I click the down arrow, there's other types of authentication. The only one that you might ever play with in your classes here would be the second one, which is SQL Server authentication. If you choose that, then once you're logged into your Windows account, you also have to have a login and a password. All right. So in other words, instead of using Windows authentication, which we're going to use in this class 100% of the time, if you use SQL Server authentication, it puts an extra layer of security on the database. That's what I'm trying to tell you here. And then finally, this thing right there, mine says desktop -M1J4BEF / JP And guess what? Everybody should have one that's different. That's going to be your username on this machine. So if I went to another machine, my username there would be different. So as it says here, this is how you connect to be able to go in and work with SQL Server, all right, using SQL Server Management Studio. And I do want to mention, it's not a big thing, but I'm trying to be complete here. But with SQL Server Management Studio, sometimes when people talk about it, they just say SSMS. So they use all four of the initials to make up an acronym. And the only reason I'm saying that is there may come a time in here where I say SSMS, but I want you to know I mean SQL Server Management Studio. All right. So I'm going to come in here. I'm going to go back into here. And all I want to do is click in here, connect. And you're going to notice when I do, my screen is going to look different over here than your screen will, because I've already got a lot of databases in here where you don't. All right, so I'm going to click connect. It'll take a second and boom. Now yours might look just like this, but when I go to databases here, I've got all these databases that I've created in other classes. All right. And you won't have those. You could have one or two in there. You could have, there might be a couple system databases in there or whatever. All right. So what have I done? All right. I came in and basically started up SQL Server Management Studio. When it came up in here, all I did was click connect. And that's gotten us to where I am right here. All right. Now, if you notice in here, it's all alphabetized. I previously did have a database in there called employees DB, but I got rid of it because I'm going to create a different one right now. And how do I do this? If I go and click on where it says databases there, and I right mouse click on it and choose new database, it's going to bring up some other stuff in here. All right. And it's a little quirky. It's a little different, but they're asking me in here, okay, what do you want to name your database? And I'm going to call mine. A lot of times when you create a database, you end it with a capital D, capital B. So I'm going to call mine employees DB, like that. And you may or may not have noticed that once I start doing that, I'm going to stretch these things out. Okay, I'll just do that. I'm going to make it as big as I need to here. There we go. So notice that once I started doing this, nothing's been created yet. Not until I click, I think it's the OK button, but that's what I'm going to click in a minute. But it's telling me a few things here. All right. First of all, this is going to be the name of my database, employees DB. Also notice there is a file that gets created when you create a database, which is called a log file, which is supposed to keep track of everything you do to the database. So when you add things to it, remove things from it, update things in it, etc., it is called a log file. All right. So you'll notice that my database, it says file type rows data, just means that that's going to be a database. All right. I'm not even sure what the file group means. The initial size, it says, well, I'm going to give you 8 meg. We'll never need anything that big, but that's fine. All right. And then it says auto growth. Well, if you remember when we worked with lists, and when you created a list and you said paren at the end, that list had 16 members in it. And once you reach 16, it doubled to 32. Here, once you reach 8 meg, it's going to go up to 64 meg. That's just the way that these are set up. All right. And it says I've got unlimited size. Well, that isn't true. I mean, your size will be limited by how much room you have on your hard drive, etc. Finally, it says, this is where I'm going to save this. So it's mine. It's under C:users/JP Scott. All right. Now, I'm stupid here in that I don't remember the difference between add and OK. Let's click add and see what happens. Okay, now it's going in and it's expecting I want to add something else in here, which I don't. So I'm going to click remove on here where I just added. I'm going to click remove. Now it's back. And I'm going to click OK. All right. Now, what you may notice is down at the bottom here, it now has employees DB. When you're like, well, that's not alphabetized like the rest. Well, one of the important things to work on when you do this is when you do major operations, you're going to come up here and that is your refresh right there. And if I click on it, it may not even show, but when I get out and get back in again, it should be in the right alphabetic order. All right. I'm doing this very slowly on purpose. All right, because I want you to understand what I'm doing as I'm doing it. All right, it is 9:04. Let's take 11 minutes. Come back, please, at 9:15, and we'll continue on. I'll be right back. All right, I was talking with one of the counselors. Sorry about that. So we have this new database. And what I am going to do is I'm going to just try this. I want to see if what I'm about to do is going to take this and alphabetize it. What I mean is I'm just going to close this. So I'm going to do a file exit. I'm out. Now I'm going to open it up again. So I'm just going to bring it up. It's no big thing whether it's in the alphabetic order or not, but I just want to see if it's going to put it in order. So I'm bringing it up in Management Studio again. Again, I'm just going to click connect. Go to databases, and it should be in alphabetic order now. And there it is, employee DB. Okay, so right now I've got a database. That database has absolutely nothing in it. All right, it is a database, but what I want to put into it, and there's different ways of doing what I'm about to show you. But what I want to put into it is I want to put in these two tables. I want to first create an employees table, and then I want to fill it up with information, and then I want to create an employee types table and fill that up with information. Now, not to confuse you, but it's typically done in one of two ways. So I want to show you both ways, not to confuse you. They're both going to do exactly the same thing, but the way I'm going to go about doing them is going to be different. All right. So I'm going to keep this one if I can. See if I don't know if I can do this or not. Whoops. Try that again. I'm going to see if it's going to let me keep this on the screen or not. Probably not, but that's all right. All right. So I'm going to go to my employees database right here, and I'm going to right mouse click on it. Now notice I don't want a new database. All right. So what else is all in here? There's new query, there's script databases, there's a whole bunch of stuff in here. All right. And there's also a little thing right here with a box in it with a plus sign. I'm going to click that. And now it tells me this is the stuff that's there. But if I go to tables, it's empty. These are all empty. They made these folders for me, but it's empty. So what I want to do is I want to create my two tables. I want to create the employees table, and I want to create the types table. So I'm going to do that right now. And I'm going to do that, like I said, I'll do one of them in one way and the other in another way, just so you can see both ways. I am not trying to do this to confuse you. I am not. It's just the opposite. So I'm going to go to tables. I'm going to right mouse click and I'm going to choose new table. Should be pretty obvious. All right. So now it comes in here and it says, what do you want to put in here? Well, again, remember, this is what I want to put in there. Employee ID, which is a type int, first name, which will be a varchar 50, last name, which will be a varchar 50, age, which will be an int, and I probably should have made that a lowercase because I did everything else, salary, which will be a decimal, and type, which will be an int. Okay, so that's what I'm going to do. So the first field that's in here is employee ID. Now, it's not mandatory, but most of the time, the first field that you're going to see in here is going to have the word ID. It's either just going to be called ID, or like in my case, it's going to be called employee ID. All right. And most of the time, that field will be of type int. I keep looking in here, somewhere in here, real, there's an int. All right. Do I want to allow nulls? In other words, is it possible to have an employee ID like this and have no ID there? No, I don't want to allow nulls. So I'm going to click that right there. All right. Now, what I want you to see is that as I'm doing this, down below, there are things that are happening in here. Notice it says column properties. All right. So there are things in here that either I can set or that will be set for me. What does that mean? Well, if you remember, what do I want? I want the first employee to have an employee ID of 1001, the second one 1002, then 1003. Well, by default, I don't even want to key these in. I want these to be filled in for me. And I'm going to show you how to do that in just a second. But by default, when you do that, it's not going to number them 1001, 1002, 1003, etc. It's going to number them 1, 2, 3, 4, etc. So I'm going to show you how you can change that in just a second. But before I do, I'm going to click on this field again. And over here, I'm right mouse clicking on it. I right mouse clicked on the field. And I'm going to choose Set Primary Key. And now again, I know it's kind of hard to see, and I apologize. I can't make this any bigger, but it put a little key there to show me that indeed it is the primary key. All right. And I want to come down here now. And like I said, this is a lot to throw at you, but I just want you to see this. Down here, it says identity specification. And I'm going to click that arrow. And I wonder, is identity? All right, I'm going to change this from no to yes. And then it says identity increment 1, identity seed, it says 1. I'm going to make that 1,000. And what that means is my first employee now that I put in, I will not have to put in the IDs. They'll be put in for me automatically. The first one will be 1,000. Soon as I put in the next one, it'll be 1,001, etc. So I now have in here my first field. Seems like a lot of work for that, but just so you see it. We'll do the rest of them right now. So the next one is going to be first name. All right. And that will be, notice it says in here, nchar. And it's like, oh, geez, what's the difference between an nchar and a varchar? And I've read stories about them that when they did the varchar, they screwed it up. So they made it an nchar, etc. I don't think it'd matter if we used nchar or varchar in here. So I'm just going to use varchar 50 right there. And what we're going to do is any employee that we put in here, we're going to say they must have an ID, they must have a first name, they must have a last name, all right? But maybe they were just hired and we don't even know what their age is. We don't know yet what their salary is going to be, and we don't know what their title will be. So what we're going to do is we're not going to allow nulls for these three, but we will allow nulls for these three. And again, null means unknown. So we've got first name, varchar 50, and I'm going to click that. Then I'm going to put in last name. Again, it'll be a varchar 50. And again, I won't allow nulls. All right. Then what's next? Age. Age, again, we're going to make that an int, and we will allow nulls. We just said that. All right. After that, we have salary. All right. And that'll be of type decimal. Now, when you look at this, it looks kind of funky. It says 18,0. What the heck does that mean? That means the largest salary we're expecting is going to have 18 nines in it. 999, 999, 999, 999, 999, 999. And it'll have 0 of those nines after the decimal. Let's suppose for a minute that the biggest salary we're going to put in here, nobody makes more than $999.99. So everyone who works here makes less than $1 million a year. Well, what do we have here? We have a total of 1, 2, 3, 4, 5, 6, 7, 8 nines. So I'm going to change that from an 18 to an 8. And after the decimal place, after the decimal place, we have 2 decimal points. All right, now I'm going to blow this up in just a second so you can see everything. And we're going to allow that. And finally, we're going to have in here type, which again is going to be an int. And again, we're going to allow that. All right, so let me grab this because I want you to be able to see what I'm doing here. So I'm going to grab just this right now and go over this with you so you can see it. All right, so this is what we put in. We have 6 fields. You can see that half of them, 3 of these fields, are int, so they're whole numbers. You can see that the primary key is the employee ID. It doesn't have to be the first field. The primary key does not have to be the first field. It typically is, but it doesn't have to be. All right. You can see that first name and last name are both varchar, meaning variable characters, 1 to 50 characters. You can see that the first 3 fields do not allow nulls. The last 3 fields do allow nulls. You can see that age and type are both ints. All right, age and type are both ints, and salary is a decimal, and it'll have a maximum of 8 nines, 9999, 9999, but it's 999.99. That's what that decimal that's there means. All right, so this is what we've set up so far. The other thing that we did was we did go in with our primary key and we went into that identity specification and we set it up that it was yes. All right. And we said to increment by 1 every time, and we'd start with 1,000. All right. Now, just so you know, we've created, that's our first schema. That is data definition language that we created right there, because it has the name of each field, the type of each field, and some constraints. In other words, the one constraint is that employee ID is a primary key. All right. And it has that 3 of these can be null, but this hasn't been saved yet. What do I mean? Well, what I want to do now is I want to right mouse click up here and I want to choose save table 1 and I want to give it a name. Well, the name of my database is employees DB. So I'm just going to call this one employees, just like that. And I'm going to click OK. And you can see now it's called, they put DBO in front of it. That means database object. All right. But I'm going to close this now. All right. And now I'm going to click this refresh button again. And now I'm going to go under tables. And there's DBO employees. All right. Now, why am I doing it like this? This I'm making it a lot more drawn out than it would typically be because I want you to see this stuff. If I right mouse click on it, and if I were to choose right now, select top 1,000 rows or edit, it'd be empty. There's no rows in there yet. But if I go back to design, it shows me. So if let's just say for a second, I screwed it up. I spelled something wrong or had a wrong type. I can change this. You should always double check to make sure your schema is correct before you go in and add your data. All right. I'm just telling you, that's what you always should do. So let me close this one more time. All right. And I'm going to come over to here where it says DBO employees. All right. And let's see what else is all in here. Design, select top 1,000, edit top 1,000, etc. All right. There's a bunch of stuff in here you're probably never even going to use, just so you know. All right. Okay. And if I look again, when I look in here, let's see, I'm going to go to table. What did I just do? All right. Well, I don't know exactly what happened when I did this. All right. I didn't think that's exactly what was going to happen, but that's okay. So I'm just going to close that. It's creating a new table for me, which I don't need. But I want to come there. Branch policies, facets, reports, name, information, properties. All right. If I click table, it's going to create a new table. If I go to design, you've already seen that. It's going to go to design. All right. If I go to select top rows, there's nothing in there to select. But the thing that's neat is this is our first SQL command that it's showing us. So what it's telling us is it wants to show us, it's assuming there could be up to 1,000 rows or more in here, but it's telling us with those first 1,000 rows, show us the employee ID, the first name, the last name, the age, the salary, the type from that table. All right. So it's telling us to do all that. And as you'd probably guess, if I go in here and I would say edit, it would do pretty much the same thing. Now we've got a script in here which says create to new query window. I don't like to monkey with that, so I'm just going to show you the way that I do this. And I'm not going to claim, hey, the way I'm showing you this is the best way. I'm just explaining to you the way that I do it. All right. So let's see. If I go into here by employees DB right there. All right. And I right mouse click. Now I don't want a new database. All right. But what I do want is a new query. Now I want to start filling in my data. All right. And I'm going to show you one way of filling in my data. It's almost here right now. Okay. Insert into employees values. The problem is, this would probably work the way it is, just so you know. This would probably work the way it is, but I'm hard coding these. I don't want to hard code those. I want the system to put those in for me. I want to say that again. I don't want to hard code the employee IDs. In a little bit, I don't want to code those type IDs. All right. I want the system to do them for me. All right. So I'm going to get rid of this. 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 I'm going to get rid of this and this and this. And I do have a brother, Michael, but that's what the author put in there. So now, if I try doing this, my guess is I'm not going to try it because my guess is it's going to fail because it's going to come in and look for an employee ID, which does not exist. All right. So how do I fix that? I'm going to show you right now. I'm going to come in here, and after it says insert into employees, I'm going to put parentheses in here, and I'm going to put in, parentheses here. And in the parentheses, I'm going to put in all the field names for which I do have a value. So I've got first name. I've got last name. I've got age. I've got salary. And I've got type. The reason I'm showing it to you like this is I'm doing it like this, all right, because I'm not filling in every one of these, all right? Now, I could be wrong with what I'm going to tell you, but I don't think I am. What if you wanted to put all of them in? All right, so in other words, what if I'm going to remove this for a second here? What if I want to do this, but I want to have it fill in those numbers for me? I think I can put null in there for each one of them. I think that would work. All right. I know that for most relational database management systems, it does work to do that. But I'm going to try it like this, and I'm going to hope against hope here that this works. So I've got insert into employees, first name with Jim, last name Halbert, age 30, salary 45,000, type 1, which in just a minute is going to mean that he's a salesman. This should work. All right. You know that I've done enough stuff this semester where something should work, but doesn't. So let's see if this does work. So I'm going to copy that and I'm going to paste that right in here. This is a new query window. If this works, my screen is going to be split in two here, and I'm going to have a message here that's either going to say row selected, or it'll say 8 or 9 rows selected or whatever. Let's see if it works. All right. Now, first thing to note here is strings get put in red. And to most people that, oh, wait a minute, red means there's an error. No, there's not. All right. Usually when there's an error, stuff will be underlined. You'll get a squiggly line in it. All right. Now, two things. First of all, this is a query. This is a data manipulation language query. I am telling the system to insert into the employees table these 5 fields. Now, I'm looking here and type looks like is a key word. What does that mean? All right. That maybe means I shouldn't use type because it probably has its own meaning. Let's go back and do one thing first. I'm going to close this and I'm not going to save it. I'm going to go back up and I'm going to bring up my table again. All right. I'm going to bring it up in design mode. Sometimes people do this. Notice I've got employee ID. So I'm going to change all of these. I'm going to make this employee. Oops, try that again. Employee first name. Looks like I removed the I too. And then employee last name. Then employee age. Then employee salary. Then employee type, because employee type will not be a keyword. All right, let's double check to make sure I did that right. So again, I'm going to do a print screen and I'm going to bring it up. I brought it up in here before. So I'm bringing it up here now. It's there. There. So now I've got employee ID, employee first name, and I'm going to capitalize the F and the L. You don't have to. Whatever you come up with the standard is what you should stick with. All right. So those are the changes that I'm making. I have changed nothing in here and nothing in here, but I put a prefix on these 5 fields here with employee. I already had it on there for ID. So I'm going to capitalize the F and the L, and then we're going to see. So let me capitalize the F here. And let me capitalize the L here. You go print screen again. After you've done this for a while, you know, you're not going to need to do. I'm just trying to show you, like I said, everything that I'm doing so that you can see it. So employee ID, employee first name, employee last name, employee age, employee salary, and employee type. That looks good to me. Now I will have to go back in where I wrote this query, and I'm going to have to change all these. So this will become employee first name. This will be employee last name, employee age, employee salary, and finally, employee type. All right. Now I'm going to go back and grab all, oops, I'm going to grab all this in a second. Copy. Now, what I want to make sure I do here, because I've changed this, is I want to right mouse click on it and save employee. So now my changes have been saved. Now I can close this, go back to here to my database, right mouse click, and choose New Query. Now I can paste this in. All right, and you can see it. Now, what doesn't it like? Well, it's giving me some underlines here. It says invalid name. All right, and it wasn't saying that before. So what doesn't it like? I don't know offhand. I thought that was the way that I set it up. It says invalid name. Now, if I go back again and make this first name, it's still, it's like it didn't take my change. That's all right. Then let's double check and make sure it did. So I'm going to close this. I'm not going to save it, but I'm going to come back to my database here and I'm going to refresh. All right. That's all I did was I clicked the refresh button. Now, when I bring this up again and I bring this up in design mode, it looks like everything is good. It's all been changed, but let's go back and right mouse click, do new query. Let's paste it in again. And now notice they're still showing them as being erroneous. Invalid column name, employee first name. I don't know what the problem is. But I'll bet you if I go back and make it first name again, it doesn't mind it. But that's actually, that is an error right there. All right. So I'm not sure what the problem is, but we're going to figure it out because I don't want to go on until we do. All right. So what I'm going to do is I am going to grab everything that's in here, copy it to the clipboard. All right. Now I want to just close this and not save it. All right. So I want to bring this up again. Okay. And I'm going to bring this up in design mode. All right. And I'm just going to keep looking. Whoops. I brought up the wrong one. So click this, bring this up in design mode. According to this, everything is correct. So I'm trying to figure out right now what is the problem between these two. So let's go and look in here. Says employee first name, says employee last name, says employee age, says employee salary, and it says employee type. All right. Well, once in a while, what I'm about to show you, weird things happen when you're working with this database. So I'm just going to do a file. All right. Right now, I'm going to do a file and an exit. All right. I'm going to get out and I'm going to get back in again. Bring that up. Go to our databases, find our employee DB. All right. Our table is in there. Should be good. We look at it in design mode. It should have all the new names. That's good. I'm going to close that. I'm going to go over here to my database, new query, and I'm going to paste that in. All right. Now notice I don't have any errors. Why did I have to get out and get back in again? I don't know. But occasionally that's what happens. All right. Now I'm going to try to run this query to see whether or not it works. And there's two ways you can run it. You should be able to right mouse click over here and choose execute, or you can hit the F5 key, but I always just click up here. There's a green button, just like we had the green button in our C# program, but this button says next to it, execute. So I'm going to click this. And it says 9 rows affected. What does that mean? It means it worked. It put 1, 2, 3, 4, 5, 6, 7, 8, 9 records in here. How do I know that for sure? First of all, I don't need to save this. I put these 9 records in already, so they're fine. So I can close this, and if it says you want to save, no. All right. But what can I do now? I can go back to my table, and now I can tell it to select the top 1,000 rows, and lo and behold, down below here, there they are. All right. And again, just so you see this, and as I mentioned to you earlier, I'm being very, very, very deliberate in what I'm doing here. I want you to see what's going on all the time. Oops, just grab that. So there's what we put in. All right. Now, with what I'm showing you, with what I just showed you, as far as how to set these up, okay, I think what I just showed you is the most straightforward way of doing it. All right. And I even made mistakes and showed you how you can get around those. No, I didn't make those mistakes on purpose. But notice it automatically numbered them for me. It incremented them by 1, and it started at 1,000. All right. Everything else that's in there was the stuff I hard coded in there. All right. Now, just so you see this, okay, what I should be able to do here, again, should is the opportune word. I'm going to close this. All right. And I should be able to come in here now and under employees DB here, put in another new query. Okay. Now I'm going to go back to here and I'm going to grab this. Create table employee types. And I've got type ID and job title. All right. I can, if I want to, I can change this to employee type ID. That's fine. It doesn't really matter. And employee job title. Okay. But what I want to show you now is I'm going to take this. If I take this right here and I paste it in there, it'll work. All right. What do I mean? I'm just going to show you. And I can put the semicolon in at the end. I don't need to. All right. This should work with no problem. All right. Create employee types, etc. So I'm running a query. I'm running a create table query now. And I'm going to click execute. It says commands completed successfully. How do I know? Well, notice I don't have an employee types table there, but if I refresh, all right, and I go back to tables, now I do. So that's another way that I can bring it in. The problem with bringing it in that way is, and I can add things here, like I could have typed in there primary key, etc. But since I didn't do that, all right, now I can go back in. I can close this. I don't need to save this query. But I can go and bring the table, my employee types table up in design mode. I can right mouse click on this and choose set primary key. Now it just made that a primary key. All right. If I don't want the titles, I'm going to allow nulls. But if I didn't, I could remove that. But now with this, I can come back in here and again, go down to identity specification, click that arrow, is identity, double click on it, which changes it to yes. I want it to be incremented by 1 and I want it to start with 1. All right. So I have made some changes in here. I don't have to run anything, but I do want to say a file, save all, and that should save this then. So if I close that and bring it back up again in design mode, you see the primary key is there. And if I look down here, the identity specification is set. It's yes, and it's 1 and 1. All right. What's kind of cool about doing this stuff is there's a lot of different ways that you can do it. I'm trying to show you what I consider to be the easiest way for you to work on this. Now, Doug Gagelman is teaching this right now in St. Louis, and he may disagree. He may be showing them a different way of doing it. And I'm not saying his way is better or my way is better. I'm trying to show you one of my goals when I teach this class is try to make this as intuitive as I can. All right. So you'll notice now it says columns, keys, etc. If I go to columns, what does it say? It says that I've got an employee type ID, which is a PK, meaning it's a primary key. It's of type integer, and it can't be null. Employee title, it's a varchar 50, and it can be null. All right. If I go to keys, it shows there's one key in here, the primary key. All right. And are there any constraints? No, not right now. Are there any triggers? No. Are there any indexes or indices? No. I guess, well, it automatically puts one in for the primary key. And an index is kind of like right now, if you imagine, if we were in your book and it was day one, and I said to you, what does bool mean? And you're like, I don't have any flipping clue as to what the heck bool means. You might go into the back of the book and look in the index and look up bool, see what page it was on, and then be able to answer the question. Indexes in here kind of work the same, but they're designed so it's easier for you to write queries. All right. Okay, so let's see. All right, I think I'm going to try something here, and it may work, but I think it will. I think if I go down now, and rather than like we did before, where I right mouse clicked and chose new query, which we totally can do, I think I can right mouse click on the table, and I can choose script table as, and I can choose insert to new query editor window. All right. And what it's showing me is if I were to come in here right now and write this query, don't worry about the errors. All right. This is what I would use to write it. Now, what there used to be in here is when you right mouse clicked on a table name, there was just a create in here, which I don't see anymore. All right, which allowed you to just start typing stuff in. Now, I don't know if the create to would do it. No. When you select these things that are in here, when you right mouse click and you choose script table as, and you choose any of the things that are in here, they write templates for you to show you how you can create or drop or select. So it's a good thing to start looking at. All right. But like I said, there used to be a way where you could just come in. I don't think that double clicking on it, no, that doesn't do it. But you used to be able to go in. I don't want a new table. Yeah, I don't know what it is. I'll have to check. But I can go back to my employee database. All right. And I can click on new query. All right. And now I can come back over to here. And now, again, I don't need this. It's automatically going to be put in for me. But I am going to put in here, first of all, that should be values, not value. But I am going to put in here this employee job title. So I'm going to put in parentheses here, and I can make it capital or lowercase. It doesn't matter. All right. But I'm telling it to add that one field. So 1 should be salesman, 2 should be receptionist, 3 should be accountant, 4 should be HR, 5 should be regional manager, and 6 should be supplier relations, if all this works. All right, so I'm going to copy that. I'm going to paste it in here. Good news is right now it's not showing me up. What doesn't it like? It says invalid object name employee types and invalid column name, employee job title. I've never had this happen to me before, but again, when I come in here and exit, says you want to save the changes. Well, that might be it. I don't want to save that query right here, so no. But I'm going to quit and I'm going to get back in again. You don't have to do this. I don't know why the system is making me do this right now, but we'll figure it out. I'm not worried about it. All right. So my guess is, though, if I come back in here now, connect again, open up under databases, go back to my employees DB. All right. Right mouse click on there, choose new query, and paste that in. Now notice no errors. What the hell happened? I don't know. All right. I'm not sure what happened right there. If I knew, I'd be more than happy to tell you, or how to get around it, I tell you. All right. But I'm not getting any errors. So I'm going to click the execute button and it says 6 rows affected. When you get a message like that, it worked. All right. How do I know that it worked? Well, I should be able to close this and I don't have to save it. All right. The only time you want to save a query is if it's a query you're going to be running over and over and over again. All right. And those are typically what are called select queries, which we're going to get into in a few minutes. But if I come back here now and I refresh and I go back to tables and I go to my employee types, right mouse click and select the top 1,000 rows, there they are. They're all in there. All right. Okay, fine, dandy, whatever. So I'm going to close this. Why? Because what I want to show you is I want to start to come in here and write some queries so you can see what the heck is going on. Now, what I'm going to do is, as much as I can, I'm going to parrot what they have in here. This is that thing I showed you before. But remember, I changed this. All right. In other words, I've got all this stuff in there, but I threw out the gender. All right. But I've got in the one table, I've got the employee ID, the first name, the last name, the age, and then we also added in there the salary, and we added in an employee type. All right. So I kind of melded these two tables together, however you want to say it. So when we inserted the values, I didn't insert, mine looked different than theirs. That's what I'm telling you. But the rest of this document that's in here is going to talk about queries that you can run. When you run a query, you are asking the database for information. All right. Now, with 8 records in, or 9 records in one table and 6 records in the other, you could manually look at it and tell this stuff. And I get that. But we're starting slow. What I hope to do tomorrow, just so you see this, where are we here? Is I've already grabbed another database from online for you. And where is that? That is, it's not here. That is up here. So we're going to have this, not that. There it is. And I know we'll make it bigger, but we're going to have several tables in here. All right. And we're going to have all the data is already going to be set for us. So we're just going to paste that stuff in. Why are we going to do this? Because it's one thing to go in and to write queries when you've got a simple database with a couple tables in it, and those couple tables that are in there have just a couple records in each one. All right, so we'll do this so we can write some additional queries. Then what we're going to do, and this will probably be Wednesday, is we're going to do this just to show it to you. I want you to give you an idea of what's going on in here. We're going to come in and we're going to go back to C#. And when we go back to C#, we're going to come in and we're going to write We're going to come in, we're going to write our own program, and if I can find it. And it's going to be this program. I wish I wouldn't have called it that because it was a stupid name, but it's going to look like this. Doesn't look like much. In here, well, let's do it this way. In here, we're going to be able to write any query we want on any database we want once we're connected to the database. Then when we click the button that says execute query, it'll give us all the results in here. Now, if there's 500 records, it's not going to show all 500, but it'll put a scroll bar in there so we can scroll through and see all 500 records. It'll show us how many records will return from our query. All right. We can click clear to clear everything back out and exit. Why am I doing this? Because it's going to allow me, when we go over the code to build this, to show you what is happening underneath the hood. All right. So when you go in and you do some of this stuff, what have we been doing so far? Not a whole heck of a lot, but what we have been doing, or what I've been doing, whatever you want to say, is a lot of copy and paste. All right. But I want to show you a lot of the different kinds of queries you can write. Plus, all we'll have to do is come in here and in our code, and this is what I'm going to go over with you, okay? But in our code, we're going to have to set up what's called a data string. And in here, this will be the name of our database. All right. And you might say, big whoop, big hairy butt deal, who cares? Well, Mr. Gudmested, when he has his class, he created a database. Guess what? The database is called Henry, and it is for Henry's bookstore. So we're going to use his database. All right. That said, are we going to use his database? Yes. Mr. Gudmested and I disagree on how certain things should be done. I'm not saying my way is better, but if I could say my way is better, I would. And if you say, what are you talking about? Let me explain it when we get to that point. But the point is, we can change that. And as an example, we could put the MMA books in there, the MMA books database. In fact, let's see if I can do that right now. I don't even know if this will work, but I want to try it to show it to you. All right. So there is the MMA books. What the heck is the MMA books database? That is this one right here. That's MMA books. Let me see if I have MMA books loaded on my system. I don't know if I do or not. All right. For some, oh, it kicked me out of here because I'm in C# now, and it kicked me out of being in where we just were. So let me see if I can bring that back up. I don't know if it'll let me if I'm in C#, but we'll see. All right. All I want to see is if we have the MMA database or the MMA books database in here. MMA books, it looks like we do. So let me close that. All right, so you saw this. I just showed it to you, and I'm hoping this works. I didn't plan on this, but I'm hoping it's going to work anyway. So file, save all, and let's run this. If I get an error, we'll just pretend this didn't happen. Okay, that's a great start. So I'm going to come in here and say select star from books. In other words, what the hell is books? All right, if you go back and look here, we don't have a books. Okay, customers, we'll say. Say select star from customers, okay? I'll change that from books to customers. And we click execute query. There's all of our customers. All right. And if we want to select all of our customers, and I don't know if there's any from Missouri in here, so let's check. I'm going to say where customers, where state equal MO. Notice they're all from Missouri. That's the kind of stuff we're going to be doing. So we have 17 customers in here that are from Missouri, but we have a total of 696 customers. All right, that's all of them. I can keep going, go through all of these. And let's say that most of our customers are from New York. So we could say where, state, equal, NY. Let's see if we get more than that. Notice there's 49 of our customers, and they're all from New York. This is what we're going to be doing for the rest of the semester. The reason that most of the time people like it is it's fairly straightforward what we're trying to do in here. All right. So what I want to show you between now and we'll take a break at 10:30 is I'm going to write a boatload of queries for you right now. All right. But I want to show you what they show in, this is that article again. When you do a select star, that means show me everything. That means show me every field in the table, everything. So show me all of the data. So in other words, if I come back in here and I do a new query, so I'm going to right mouse click on the name of my database and choose new query. And I say select star from employees. Notice there's even IntelliSense right here. All right. So once I say that and I click my button, there are all of my employees. That's everything. If I change this to employee types and I run it again, there's my 6 types of employees. So select star will give you everything. All right. And that's exactly what they're saying in here. So it says select all from whatever table you're referencing. Now you might say, is there a way that I can select things from both tables? We're going to look at that in just a minute. But it is select star from something. Now you don't have to do this. I put it all on one line. Quite often what you're going to see is people will write it like this. Again, select in all caps, star, and then from, and many times that's what people will do is they will take their keywords and they will capitalize them. If I run this, it's going to look exactly like it did here. All right, basically it just refreshed the screen. All right, now going back to the other table. So select star from employees. Right there. You've already seen this. We get the ID, the first name, the last name, the age, the salary, and the employee type. All right. What if I don't want everything? Then I can just ask for what I'm looking for. So I can say employee, first name, and notice I can use the IntelliSense, employee, last name from employees. And when I run this, I only get the first name and the last name from my employees table. Now, I realize it's a little hard for you to probably see on here, but I think you can see enough where hopefully at least it makes sense. All right. Now, not that this is a big thing, but I want to show you a couple things about this, such as, well, the name of my heading here is the same name as my field name. What if I don't want that? What if I want this to say first space name and the other one to say last space name? Then I can come in here and add what's called an alias. So I can say as, notice it's another keyword. Then in single quotes, I'm going to put in first name, and then I'm going to do it again as last name. Those are one way we can add aliases. Now watch how these headings change when I run the query. All right, looks a little bit nicer. It looks a little bit more professional to do it that way. Again, you may agree, you may not agree. And either way, that's fine. All right. Now, when you look in here, I'm just running a bunch of queries just to show you, and you're not expected to remember all this or anything else. But right now, I'm telling it to show every employee, everyone. Now, I'm only showing their first names and their last names, but I'm telling it to show everyone. I can put in what's called a clause in here, so I can use where. All right. And I can see it's giving me errors because I got to say where what. All right. But what if I want, as an example, all employees whose last name starts with an H? So H for Halbert, H for Hudson. I only want those. Now you might say, well, that's a stupid query. And you know what? You'd be right. Sometimes as you're learning this stuff, we will write convoluted queries. I mean, what's the chance of your boss saying, hey, how many people who work for us have a last name that starts with H? But it's to show you how to write the queries. So I can say where employee last name, whoops, employee, where employee, oh, it's not picking up now, but that's okay. Last name, okay. And it doesn't like that because I referenced it in here. I think it actually wants me to call it now last name. Where last name, okay, that doesn't like that either. I'm going to get rid of this because I want these queries to work. All right. Eventually, everything, really everything we do will work. All right. But I'm going to say here where employee last name, all right, is we want it only the ones that start with an H. So we're going to put in here like, which is another keyword. All right. Oh, it's giving me errors because the where has to go under the from. That's why I'm getting the errors. There we go. All right. So we want to say I can still put those back. So I can say in here as first name and as last name there. All right. From employees, where the last name, I'm going to put like in capital letters. Like, well, I wanted to say it starts with an H. When you are checking this again, this is case insensitive. So I can start it with an uppercase H or a lowercase h. And I'll put in here H. All right, now if I just did this, it wouldn't find anything because that says, show me all employees with a last name that's equal to H. We don't have any of those. But we can put in here a %, which is a wildcard character, which says, show me any employee that has a last name that starts with H and has anything after it or nothing after it. So if we run this and I click and execute, notice I get Jim Halbert and Stanley Hudson. All right. What if I want the ones that doesn't start with H? Well, what if I put in here not like? What does that give me? And you'll notice I get 7, but if you look under the last names here, all right, we don't have Hudson, we don't have Halbert. But when you look at this, you're like, oh, wait a minute. These are in order, 1, 2, 3, 4, 5, 6, 7. Okay, but these aren't in order. What if I wanted it in order based on the last name? Then I can come in here and I can say order by employee last name. All right, just like that. And if I run it, now the last names, it says Beasley, Schutte, Martin, Henderson, Scott, Palmer, Malone. After I run this, it now says Beasley, Flenderson, I guess that is, Malone, Martin, Palmer, Schutte, and Scott. It's in alphabetic order. Another thing you may or may not have realized, now I'm going to get rid of this right away. I'm going to grab every bit of this. And I'm going to hit enter here. All right. And I don't remember when this came, but it was something like, I think here. All right. Why did I do that? Because that's link. So you can see how similar, yet how different it is. This is SQL. This will only run on database information. This is link. We'd have to make some changes, but we could get it to run with a database. But with what we were using last week, we were running it with a list. You cannot run SQL on a list. All right. But the point is, it's the same information. We're just massaging the order in which we're putting the statements. So when you work with SQL, it's select one or more fields from one or more tables. Then you can optionally put in here where and put in criteria, and you can optionally put in an order by, which is 2 words for SQL and 1 word for link. All right. And you could do this. We could do this in, whatever we wanted. We could do it by first name. We can also order by more than one thing. All right. Okay. So I showed you select star to get everything. Now remember, when we did do that, when we did say select star from employees. All right, it gives us everything. You've already seen that. But we can put an order by on anything we want in here. Okay? So for instance, if we said order by employee age, okay? This will work. It's in select star. It says commands completed successfully. Select star. Why did it do that? Well, that's interesting. There it is. So the age 29, 30, 30, 31, 31, 32, 32, 35, 38. Well, what if we wanted then? We wanted, okay, if there's a match, then we want them based in order of salary. But instead of doing this, we didn't write this, but the system does this. That means put it in ascending order. But now I want to tell it, if there's ties, do it by employee salary, but do it in descending order. So in other words, when you look here, Jim Halbert and Pam Beasley are both 30. They already are in descending order. These are in descending order. These already are. So this isn't going to change the order at all. So let's make this one. In fact, let's make this descending. All right, and we'll run it again. So now notice it's 38, 35, 32, 32, 31, 31, 30, 30, 29. So you've got the ability, is what I'm telling you in here, when you start working with this stuff, all right, to take anything you want and do virtually anything you want to do with it. So again, if I only want some of the fields, I have to list them. I could list every field. The reason I might want to do that is I might want to say, for example, select employee ID as ID, and then for next, employee first name as first name, and keep going like that. All right, I might as well just do it all. So employee last name as last name, employee age as, oh boy, as age, employee salary as salary, and finally, employee type as type. All right, and there's going to be no errors in there, but except I'm going to have headings now. And you can see it's a little nicer to look at. Okay. All right. Again, those aren't big things. I'm just trying to show you some of this stuff. And again, we are using the crawl, walk, run mentality. So we're crawling right now. Tomorrow we'll walk. All right. So as we take a look in here then, and I jump back into this article, we did select star, we did select with field names. All right, top allows you to query for the top designated rows. So top 5 would only show you the 5 at the top. I'm not going to run that. I think you can figure out what would happen. All right. Now, this is an interesting one. This isn't going to make a lot of sense now, but let's just look at it. All right. So I'm going to say select. We're going to just say employee age as age from employees. No order by, no nothing. All right. And then run this. And you can see what we get: 30, 30, 29, 31, 32, etc. What order is that? That's the order that we put them in back when we were over here. 30, 30, 29, 31. That's the order they got put in. All right. That's not a problem. We can do it just like that. That's not a problem. All right. But what if we only want the ages? We don't want there to be repeats. I want to say that again. We want 30, 29, 31, etc. If we do this now and put an order by in here, so I'm going to put an order by. All right. And you can mix case like that. It's kind of poor, I think, to do that, but you can. So order it by age, and we can do that. And we get 29, 30, 30, 31, 31, 32, 32, 35, 38. But if we do that and we come into here and we put in the word distinct, that says don't show us any matches. In other words, if we've got 2 employees that have the same age, only show me the first one. All right, so distinct says remove any repeats. Now notice it's 29, 30, 31, 32, 35, 38. All right. What if, and I'm just throwing some queries at you here. What if we didn't care about that, but what if we wanted to know who was, not who, but what's the oldest age of an employee working here? What's the oldest age? And I just say select max. And I should get 38. And I do. What if I wanted the youngest? I would select min. And I get 29. Now, using max and min, and there's other ones we're going to use, those are called aggregate queries. And they're called aggregates because they go through the whole list and just give you one thing back. What if I wanted the average employee age of all my employees? All right. It says here the average age is 32. Is it exactly 32? I don't know. But what I can do is I can say, I want you to round and I want you to do the average employee age, and I want you to do that to 2 decimal places. All right. And I'm going to run that. And it still says 32. What it does when it does this is it goes and it adds up every one of these ages. So 30 plus 30 plus 29 plus 31 plus 32 plus 35 plus 32 plus 38 plus 31. Let's see if we manually did that. if we get the same answer. If we don't, I look kind of foolish. So 30 plus 30 plus 29 plus 31 plus 32 plus 35 plus 32 plus 38 plus 31. I think I put them all in there, and I think I put them all in there correctly. That's 288. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 employees. So if I divide that by 9, I get 32. All right. If I go and change the, age of one of these employees, for example, I get a different number. All right. And again, all I'm trying to do here is to show you some of the things that you can do with this. All right. There's a count. What if I wanted to know how many employees we had? All right. What if I wanted to know how many employees we actually have working here? Now, well, you can count them right here. There's 9 of them. I get that. But what if there were 9,000 or 9998 or whatever? So I can come in here and say, select count, and I can just put in here star. I don't even need to choose a field from employees. And it says there's 9 of them. I could just put in here employee last name because there's 9 last names as well. I get the same answer. But typically when you're using count, which is another aggregate function, you just use star with it. All right, let's see. I'm going to try 1 or 2 more and then we're going to take another break. I don't know if this is going to work, but I think it is. I'm going to say select star from employees, group by employee age. I think this will work. I believe it will, but we're going to see. No, it's invalid because the select list is not contained in an aggregate function or in a group by clause. All right, so we'll do a count. All right, we'll see if that works. We have 1 employee that's 29, 2 employees that are 30, etc. So well, he's not showing that. Then I'd have to come in here and say, so employee age, comma, count star from employees, group by employee age. All right, in fact, I don't even, yeah, I'll try it like that. So again, there's 1 employee that's 29, 2 that are 30, 2 that are 31, 2 that are 32, 1 that is 35, and 1 that is 38. And again, what I'm trying to get across to you is how you can come in here and you can write lots of queries to do lots of different stuff. All right. So what we're going to do is we're going to take a break. It's 10:30. Let's come back, please. Let's come back at 10:40. Let's make it 10:41 because it's almost 10:31. So let's come back at 10:41. We're going to finish this, and I'm going to head right into the next database we're going to create. See you at 10:41. All right, it's 10:41, so I'm going to start back up. I've gone through now most of the stuff that's in here. We went through distinct. We talked about count. We talked about max and min. We've talked about the from statement because that's the table you're getting stuff from. We've talked about the where statement, which allows you to put criteria onto your query. Now, some of the stuff that's in here, I mean, just so you know, because I'm trying to be complete here. So here we've got, let's do the age again. So select employee age from employees. We're not going to group by or anything, but we'll say where age is less than or equal to 30, as an example, not age, should be employee age. Okay. And we can even, if we want, we can order it by employee age. All right. And what you'll see when we run this is we get 29, 30, and 30. That should make sense. In the same way, if we said all the ones that are greater than this, and let's do an order by, but let's do it in descending order. All right. And if we run this, we get 38, 35, 32, 32, 31, and 31. All right. So you can use mathematical operators. What if we wanted, and this is kind of bad, but I'm going to show you a bad way and then a better way. What if we wanted only, let's say we had no idea what the ages were in here. So we want only employees that are 30 or 31 or 32. That's it. We could come in and write it like this. We could say we're employee age equal 30 or employee age equal 31 or employee age equal 32. And say, let's say select star from there. Okay. And we will order it by age in descending order. That's fine. So what is it showing us? It shows us the two people who are 32, then the two that are 31, then the two that are 30. And that's okay. There's nothing wrong with that. But you can't say we're employee age equal 30 or 31 or 32. You cannot do that. But there is a shortcut for this. And that is, instead of writing it like this, and I'll leave this one up here so you can see the difference. We can say select star from employees where, from employees where employee age in, and we can say 30, 31, 32. And then do our order by again if we want to. So order by employee age, DESC. All right. So I will take this one out of there and run it, see if we get the same information. And we do. So you can use in to put in a list. All right. If I wanted everybody who was not 30 or 31 or 32, I could say not in. And now it gives us 38, 35, and 29. Okay. Now, what if we wanted to do something with salary? So I'm going to select star from employees again. Okay. And there's the salaries. So there's 45,000, 36,000, 63,000, 47,000, 50,000, 65,000, 41,000, 48,000, and 42,000. All right. I mean, I can put in stuff like this. I can say select star from employees where employee salary, greater than or equal to, let's say 50,000 and employee salary less than or equal to 60,000 as an example. I can do that. And it shows us there's just one that meets that criteria. If I changed it from 60 to 65, I think there's more. Yeah. Now we've got 3 of them that meet that criteria. All right. And what is the shortcut? I'm trying to remember. because there is a shortcut for doing this too. So let's see. Don't remember it right now, so I'll try to remember it for you tomorrow. But there's a shortcut for doing that as well. All right. So we did the less than. You can put multiple conditions in here, and I've even shown you that. All right, here's one where age is less than 32 or gender equal male as an example. We did this. All right, let's go back to this one that we did earlier. So select star from employees where employee last name like, and we'll do S this time, S star. That should find Scott, and I think, I don't remember what the other, Schulte or whatever it was. And that's what it finds. Again, we can say not like, and it'll show us everyone except those people. We've done this before, but we can also do this. We can put the S on the end, which says only show us people whose last name ends with an S. And I don't think there are any. Oh, what did it do? Select star from employees where employees. Oh, yeah, because we got not in there. Now, this is a real important concept, and I may have mentioned this last week, and that is the query is valid. There are no records that meet the criteria we put in. The query itself is a valid query. I want to say that again. The query itself is a valid query. That would be like saying, select star from employees where employee salary is greater than or equal to 1, 2, 3, 4, 5, 6. There is nobody who makes $1 million. So we get the same thing. All right. So if you write a query and you don't get any errors up here in the query window, but in your query results window, if you just get this, just the headings, that means that there's nothing that meets your criteria. All right. There is null, but we didn't put anything in there with nulls. So that's not going to find anything. We could put it in, it's just not going to find anything. All right, now when you look here, select star from employees, where first name equal Jim, all right, and last name equal and first name equal Michael. Well, first of all, it's not going to find any because you can't have two first names. But if you do it like this, that was that in that we used before. All right. And we did a group by. So we basically have gone through, we've been doing some order buys. All right, again, it does ascending by default. You can put ASC in there, although it's considered redundant. If you do want it in descending order, you must put in DESC. And it's interesting because as you get more into this, DESC means two different things. You can also use it to describe things, but in this case, it means descending. All right. That's everything that's in here. So what I wanted to do next was to go back and actually look at the chapter. All right, because we haven't done the chapter at all other than I showed you that picture. So let's go back and let's look at chapter 19, an intro to database programming. I don't know if you found it better to do it like this or if it's worse to do it like this. I just figured showing you a bunch of examples would make it easier once we started to talk about everything that's in here. So the first 4 pages talk about client server systems. Then we get into relational databases, which is what we're using. Then the last 7 or 8 pages, all right, go into using SQL. All right, and I'll show you a couple things that I didn't show you previously, but we'll see them. Okay, so the first thing talks about client server systems. Now,
At the school I used to teach at many years ago, probably 25 years ago, we would have a class called Client Server 1 and Client Server 2. That was the day when basically all you had were laptops, desktops, and you had, like mainframe or big computers. You didn't have cell phones where you could do work on. You didn't have tablets. All right. So as it says, these first 4 pages are designed to show you what a client server system is. The client in this class, what we're doing is we are using our machine as both the client and as the server. How do I know that? We are writing queries against a database that is on our own machine. And it is showing you the answers to those queries on our own machine. So our client server system really only has a client. That said, when you look in here, let me close this. I don't need to save. So let's exit and get back in again. Let's pretend for a moment that you worked for a company and that company that you worked for had, let's say it was Amazon. Well, if it was Amazon in here, you would conceivably, when you click the down arrow, have multiple different servers. All right. You might have a test server, which might be your own machine, might not be your own machine. You might have a production server where the actual data was. You could even have other servers. All right. But again, what I'm telling you is with what we're doing right here, our client server system is literally one machine. All right. So they say there that in a typical client server system, the clients are the PCs, the mobile devices. The network is what you need to connect the clients to the server. And the server is a computer that's going to hold all the database information. And again, we've talked a little bit about this in earlier chapters. I believe we even talked about this in those of you who are in the AWD1000 class. In a local area network, the computers are in physical proximity to one another. So, as an example, if you go to the Wentzville campus and you go into either of the computer labs, those machines are physically connected to one another and they're connected to a server that's in the room. If you go into the St. Louis campus, the same type of thing. But there is a physical connection, an actual connection. On the other hand, the machines that are in Wentzville can, some of them at least, can converse or can talk to machines in St. Louis. But that said, those machines are not physically connected. There's not wiring that's run over 40 miles between Wentzville and St. Louis. It runs under the highway or whatever. No, rather, they're connected with a wide area network. All right. So they show this. And again, we've seen this kind of picture before in other classes. If you want more than I'm giving you or you don't like my definitions, take a look at what's in here. I think it's going to say the same thing. All right. The software components of a client server system. All right. One thing you have in there is called a NOS, which is a network operating system. As it says, it manages the functions of the network. The server requires some kind of a DBMS. We already talked about what a database management system is. It's the software that allows you, for lack of better words, to perform both data definition language and data manipulation language statements. The DBMS, as it says, manages the databases stored on the server. All right. And it says also, each client requires application software to run. The application software we're using in this class is we're using C#, but we're going to now start using C# in conjunction with SQL Server. All right. I want to say that again. We're going to use C# in conjunction with SQL Server. And we're going to write queries that we're going to use against the database. These queries that we write will be written in SQL, or as it's pronounced typically, SQL. So you'll notice when you look there, and they're very much simplifying this diagram. All right. It's possible if you write an SQL query, it could go to one or more different servers. It depends on where you're working, how your server setup is, etc. But in this example, you sit at your computer like we are right now, key in a query. All right. Tell it to execute. And in this case, it's going out to a different machine that actually houses the database to give you your answer. And again, as I mentioned previously, in our case, with what we are doing, we're using one machine for both of these. All right. So as I mentioned, look, 54 years ago, Dr. E.F. Codd, he was a mathematician, and this whole relational database theory was based on mathematics. All right. Years ago, tell you, make it short and sweet. Maybe you've seen this. If you've ever stayed home on New Year's Eve and watched, they'll have a thing. I think it's on ABC. They call it Rockin' New Year's Eve with Dick Clark. All right, Dick Clark had a show on TV back in the 70s, probably, called American Bandstand. Maybe it was even the 60s. I don't know. But the point is, somebody asked him once, because he used to bring in all the big acts that, the Beatles went on there, etc., all these groups. And somebody asked him once, I was watching an interview with him, and they said, Dick, are you the father of rock and roll? And he said, no, but I'd like to think I was there assisting at the birth. That's what E.F. Codd is. He basically was the one who was assisting at the birth when relational databases came to fruition and started to be. All right. Why do you even care about this? Notice it says this type of database eliminated some of the problems associated with using files. This is the biggest one. You reduce data redundancy. The idea is you store data once in one place. Going back to the example we looked at before, remember, I made this table. All right. In the article that we looked at, they didn't do that. In fact, for every employee that they put in there, you had their type of job. And as I mentioned to you, if one person comes in here and spells accountant wrong, you're going to get errors, or puts human resources instead of HR. But if I wanted to go and add more types, if I wanted to go in and add more types into this, what would I have to do? All right. Well, I guess they'd be in here. But again, what if I spell them or spell them in different ways, or whatever. Whereas if I go back in here with the way I did it, if I want to add a new type, I would just go in and modify this table and add a new type. And I'll show you how to modify that in a minute. All right. So data is stored in tables. Each table, in many ways, I've used this example before. In many ways, tables are like Excel spreadsheets. They're not the same, but in many ways. With an Excel spreadsheet, this is called a cell. It is the intersection of column B and row 2. It's B2. All right. When you work with databases and you're working with records and stuff, it's kind of the same way. It's rows and it's columns. But rather than it being in column order with the column first, it's in row order with the row first. So this would be row 2, column B. Right? Says in practice, the rows and columns are sometimes referred to. Rows are also referred to as records. Columns are also referred to as fields. There's even other names. For instance, you may remember this because this is a term we learned earlier in the book. Records or rows are also referred to as tuples. All right. If a table contains one or more columns that uniquely identify a row, those are the primary key. You saw when we made the primary key. All right. A primary key, again, is a unique record identifier. If the primary key has more than one column in it, it's called a composite primary key. All right. One thing you should not do, one thing that you should not do with this is primary keys should be unintelligible. What does that mean? If you look here, if somebody finds out my primary key with what we had, well, what we did before, remember, this was 1001, 1002, 1000, etc. No biggie. If they find out this is 1, 2, 3, 4, 5, 6, no biggie. But you should never take a field like social security number and make it a primary key. Some people argue, well, it's unique. Yes. But if somebody finds out your social security number, they can wreak havoc on your life. All right. So you should always make sure that the primary key is unintelligible. Again, meaning that if somebody finds out what your primary key is, it's not going to hurt you. All right. There's other constraints. Okay. You could sometimes two different fields could be a primary key. So you choose one of them and the other one you make a unique key, which means it still has to be it has to be distinct from all others. Indexes, I already mentioned. It's a way that when you are writing queries, it can make the query run better by putting indexes in. All right. So here is an example of this MMA books. And what is this? All right, the primary key. So this looks like the products table. So notice there's a product code. They in here, all of the fields, I should say, the primary key is not a numeric field. It's right here. Could we have just put in something called product ID? Sure. All right. So there's the code, there's the description, there's the price, and there's how many we have in stock. When you want to relate tables in a database, I'm going to show you this right now. Let me go back and show you it on here. So our boss comes up to us. All right, let me get back in here. I guess I got out. I'm going to get back in.
So our boss comes in and says, or my boss comes in and says, Jeff, I want you to go and I want you to create a report for me. I want a listing of all employees and I want their first name, I want their last name, I want their salary, and I want the department that they work for. All right, or what their job title is. That information is in two different tables. So how do I do that? You create what's called a join on those tables. All right, how do I do that? Let's go to the new query here. And let's say select, and we'll put in employee first name, employee last name, employee salary. And the other one was, it's employee type, but I think that in here, let me look. I'm going to just grab these so I don't have to retype it. Let me bring in this. We called it employee job title. Okay. So, and employee job title. Now, can I do this? Watch this. All right. Well, first of all, it doesn't like something. What doesn't like? Again, I know I've never gotten these types of things before where it says invalid name. I don't know why it's doing that. What if I say from and I give it both table names? So I say employees, comma, employee types. Believe it or not, it's probably going to work. All right, it's probably going to work. Now it's giving me an error here, and it says invalid column name. Let me grab all this, see if I called it something else. Employee types, that's all correct. Oh, it's gone. All right. I think it's going to run, but it's going to give me a wrong answer. All right, it says could not find stored procedure of type Y from employees, employee types. Employee types. Could not find stored procedure Y. I don't know what that is. But let me show you how we would write this. I'm going to show you the best way to write this. All right. And that is, well, this one, employee first name, that exists in a table called employees. I'm going to put E dot there. Don't worry if we get errors. E dot here, E dot here. And this is in the other one, which is called employee types. I'm going to put ET dot here. All right. And now I'm going to say from employees E. What I just did was I did what's called a different type of aliasing. I said, hey, whenever we refer just to E, it's as though we typed in employees dot employee first name, employees dot employee last name, and employees dot. And we could have done that. We could have typed all that in, but it's a lot to type in. All right. Now, been a while since I've written one of these, but hopefully I'm going to do it right. Inner join employee job title, ET on, I probably did it wrong, but we'll see, on let me grab this. So here we call this employee type, and here it is called employee job title. Okay, employee type ID, and employee type. Okay. Let me close these. Let's close all of them, and I don't want to save. Okay, so let's do a new query. All right. Inner join employee types. ET on E dot employee type equals ET dot employee job ID. All right, first let's see if it worked. And I'm gonna hold this here. All right. There you go. We've got information from two tables. From the employee table, we've got first name, last name, salary. From the job title one, we've got the title, salesman, receptionist, etc. All right. How did we do that? Well, we said what we wanted. We can still do an order by. So we can do, for example, an order by. And now let's do it by ET dot employee type ID. Something like that. I think that'll work. Maybe not, but I think so. Now it's got our salesman together, followed by our receptionist, followed by our accountants, etc. So there's some order. So how did we do this? Well, we have to let it know what fields we want. All right. We technically, just so you know, we didn't need this. We didn't need this. We didn't need this. And I don't even think we needed this. All right. We didn't need any of those. What do I mean? There's only one table with the word, with the field employee first name in it. There's only one table with the field employee last name in it. There's only one table with the field employee salary in it. And there's only one table with the field employee job title in it. But by putting these in, we are letting the system know, and anybody who looks at it, what table we're grabbing that information from. We're telling it to do an inner join. An inner join means that they match. So whenever the employee type, all right, that was in here matches the employee type ID, which was in there. So we're basically making sure this was the 1, 2, 3, 4, 5, 6 in the employee table. This was the 1, 2, 3, 4, 5, 6 in the employee type table. All right. Now, I do want to show you one more thing. Back, let me grab that and copy it. But I want to show you something, and that is, this is considered more the, for lack of better words, kind of the newfangled way of doing this. But I want to show you, back when I was writing these, there was another way of writing it. All right. I think the other way is easier. Draw your own conclusions. So rather than saying inner join, all you said here was where. All right, where employee type equals ET. Now it doesn't like something. What doesn't it like? It says the multi-part identifier. Oh, okay. From employees E, employee, the other table. So we need employee types ET. Now the errors are going to go away. Come on, go away. All right. And I'm going to see if it works now or if it doesn't work now, but just give me a sec. All right, it says invalid column name, employee type ID. Well, ET. It's complaining about that, even though that was valid doing it the other way. I think to do that, I have to list it here. So let's see. ET dot employee ID. All I'm trying to show you, and not very well, but there's more than one way of writing this. All right, if I remove everything and get it back to where it was working, all right, this is considered the way you should write it now. All I'm showing you is this was not the way I was taught to do it. All right, I want to show you 3 more queries and we're done for the day. All right, the first one is, I'm going to select star again from employees, just like that. And guess what? My brother Michael Scott just got a raise. All right. So I want to update his salary. He now makes 75 instead of 65. And I want to show you a bad thing that you don't want to do. I'm going to say update, and I got to give it the name. So update employees, and I want to say set employee salary equal, employee salary is one word, equal to $75,000. Now, if I do that, you might have already guessed that's going to change everybody's salary to $75,000. Everybody's. I can come in here and do this. I can say where employee first name is equal to Michael, and employee last name is equal to Scott. I can do that, and it works okay. Except, what if it's a real huge company and I have more than one Michael Scott? That's going to change every occurrence of Michael Scott. So what I want to do is I want to find out their employee ID number. Remember, those are unique. So I can say where employee ID is equal to 1005. Now, when I run this and I click execute, one row affected, if I refresh my table and I bring it back up again, so let's just go back down to the tables here and let's look at all the data. And you'll notice when I go to Michael Scott, it is now $75,000. That's how you do an update. All right, let's add me in here, and then I'm going to delete me so you can see how to do a delete. All right, so I'm going to come in here and I'm going to say insert into employees. All right, values. And I'm going to put in here Jeff, Scott, there. Let's see. I'll give me a nice salary. And I'll say that I'm in number 1. Doesn't matter. All right. So no errors, it looks like. Put that in. Execute. One row affected. That's good. Refresh our table. Let's bring it up again. And you'll notice I'm in here now. What's weird is, for whatever reason, it put me in as 2001. Not sure why it did that, but it did. But everything else looks fine. All right. Now I want to, it's the same kind of a situation as when we did the update. I want to say delete from employees. If I do that, it's going to remove everybody. And if I say where employee first name equals Jeff and employee last name equals Scott, that'll work. But if there's more than one Jeff Scott that works for the company, they're all gone. So again, I'd want to come through here and I'd want to say where employee ID is equal to 2001. Now, when I run this, one row affected, if I refresh my table or the database and run it, I'm not in there anymore. Now, the other thing to realize about doing that I want to mention to you is that particular ID has been removed and we can't get it back. All right. In other words, that's gone. So sometimes what people do when they delete is they don't actually delete them, but instead what they do is they create another table where they take people who have been, left the company or whatever, and they put them in that table. All right. Just so you're aware of that. So quickly today, I have shown you, all right, we learned how to get into SQL Server. We learned how to create a database. We learned how to create a table. We ran several select queries. And now we just ran one join query, and we ran a couple of other queries too. We ran an update and we ran a delete. That's what I had for today. All right. I will tell you tomorrow we're going to continue on with this. All right. And I'm gonna quickly finish the chapter up because there's a couple more pages. So we're gonna quickly finish we'll finish this chapter up now, but tomorrow we're going to continue with this. And we're going to keep writing these, and we're going to eventually write ourselves a C# program that's going to allow us to do a lot of this stuff. Now, one thing that's in here that we haven't talked about yet is a foreign key. I want to wait on that till tomorrow, and I'll show you an example. This example isn't bad, but it's not great. If you have time, please try to go in and read the chapter, even if you just page through it between today and tomorrow. All right. All right. We talked about nulls. There are defaults you can add. I'm not going to get into that. These are some of the data types that you have with SQL Server. Is this a full list? No. I went online and found this. Where is it? Where are you? It's in here. There we go. There's your data types. So notice there's a lot of them. All right. And we're going to just concentrate on a few: varchar and int and decimal. Char is fixed length. So if you had a state field, instead of making it a varchar, you'd make it a char of 2. So it would have, the state abbreviation in it type of thing. All right. So let's see. This is the design of their book, their database. We talked about it a little bit. Like I said, I'd like you to read this. I would really appreciate it if you would. How to use SQL to work with this. This is where we'll come back to this tomorrow. All right. We've talked select already. We'll continue to. We'll talk about how to join. You saw an example, but I'll show you more. We'll do an add, an update, and a delete into this table, or into this database rather. That's it. Please try to read this by tomorrow, please. And like I said, or at least page through it. We'll pick it up there, but we're going to use the MMA books tomorrow as we look for things because it's got more records in it. All right. I will talk to you then. Have a good rest of the day. Thanks a lot.